Now, the first topic that I'd like to share with you is the research that we've been conducting on proteomics. The first inspiration that we've been taking has been from natural language processing. So, how is this related to proteins? Well, let me take you through language modeling and what technologies that we've been using in language modeling so far, and how we've been able to transfer this for proteins research, and how we've been able to get state-of-the-art performances using that. So this is a classical example of how to take something that's a bit more methods oriented and then apply it to a field like proteomics. Now, the first key technology that we've been looking into and that has allowed us to make massive gains on proteomics is language modeling. Now, you might ask yourself, what is language modeling? Some of you might have an NLP background, but if you don't, I'll take you to a quick tutorial of it. So if you have a sentence such as insulin should be taken in the, how do you guess the next word? That's the key task in language modeling. And you could say, well, it should be taken in the morning, it should be taken in the lunch break or afternoon. But you could also have other words in here. You could have the whole English vocabulary. So language modeling is calculating a distribution over what should the next word be. And classically, this has been done with n-grams. So this has been researched for decades using n-grams model and statistical learning algorithms, where you would go in and you'd say, well, given we have this sentence, let's just look at the last word or the two last words and say, given I've seen in there, what would be the chances that I would see morning after that? And now it's that exact type of technology that we are looking for when we want to understand a much more complex language, which is the language of proteins.